Hey there, everyone. Ryan Schul. This is my channel, Straight Data Science. Welcome. So, in the topic or the project today, I want to try to analyze like what you need to do if you have names and addresses and zip codes and phone numbers and who knows what else, customization things in one single column in one table in a database. And I know this sounds weird, like names should be names, right? You should have your first name, last name, address, zip code, phone number, email. Each one has a separate column, right? In the data science world, we call that feature. In the database world, it's called columns, or in Excel world, it's called columns. You should have their own separate and distinct features or columns, right? But I've been in Wall Street for 22 years. I've seen companies jam everything into one single column in the database. It makes no sense whatsoever, okay? There's no standardization, super mixed content, super confusing. I don't know why they do this, but listen, I've been around for more than 2 decades in the professional services world, and I've seen everything. Okay, so this is embarrassing. It's unfortunate, but sometimes you encounter this, and you have to offer a solution. Right? This is a problem, and we're going to come up with a solution today. So we're going to try to normalize a single mixed content column into separate and distinct columns, which it should be in the first place. But sometimes things get just jammed up and stuffed up into one single place. That's unfortunate, but that's reality. Sometimes it happens, right? So we can take this concept and improve data quality. We can enable accurate filtering and queries for different data types or different data needs, right? And answer different questions. This supports downstream automation, right? I've worked in the automation world for 10 years, the first 10 years of my career. If everything is standardized and pretty tight and pretty clean, you can automate the task. If it's not, you have to do some data cleaning to get it into a state where you can do the automation. This facilitates validation and reporting, error checking, boosting machine learning performance, right? If you put one single column with every single thing in the universe jammed in there, the machine learning model is not going to know what to do with it, just like a human being. Like if you tell everything to a human being, everything in the universe, they're not going to know what to do with it. You have to compartmentalize and segment that and structure that into a form that makes sense, right? Once you do that, you can improve data merging and data enrichment and what's it called? Enhancement, refining, data refining. You can start to do these other substructures, right? But if everything is just tightly coupled together and all aggregated into one single spot, it's not going to make sense, right? But you see this once in a while. It's not too common, but you see it. So if you encounter this, let me show you how to handle that. That's what this project is about today. So we are going to look at email addresses, people's names, company names, zip codes, phone numbers, cities, right? Again, all jammed into one single column. It should not be that way, but that happens. That happens more than you think. So let me go ahead and create a simulated data set. So I'm going to use the Faker library in Python, right? And it just creates like a simulation of emails, corporate names, corporate entity names, zip codes, phone numbers, cities. And we're going to take all this and then consolidate everything together onto one spot. And then we're going to parse everything out into a state or into a form that it should be. So you can see right here, we have 500 rows. You can see right here, this looks kind of like a phone number. This is probably a person's name or hyphenated name, probably first name and last name. This looks like an email address. This looks like it could be a zip code, and this looks like a person's name. But again, everything is in one column. Shouldn't be this way, but it happens. This happens, right? So we can create a user-defined function. We're going to use regex. RE is regex, okay? And anything that looks like an email that has this kind of combination with a ampersand embedded in it, I Googled this. This is how you can identify an email. A phone number is going to have a bunch of combinations of numbers together, right? Normally 10 numbers. You'll have 3 plus 3 plus 4. You'll have 10 numbers. And it kind of like follows a certain pattern and a certain like ways to identify this, right? That's why we're using regex. So this is the way to identify a zip code. Usually have 5 characters, at least in the United States. In other countries, it's different. We're just going to focus on the United States. If you look globally, then the analysis would have to adapt to that and be a little bit different. So There's a way to identify names, people's names. We can use regex for that, uppercase, lowercase, A to Z, and there's a certain pattern. And for corporate names, usually you'll have incorporated, corp, LLC, limited, technology, solution, group, systems, things like that. So like there's certain patterns that you look for. And if you find that, you can say, okay, this is probably a company. If you don't find those patterns, okay, it's probably a person's name. If you have 5 characters or 5 numbers, and by the way, a zip code isn't really a number. It's actually like a label. It looks like a number. My zip code is 11101. It sounds like 5 numbers together, 11101, but it's actually not a real number. It's more like an identifier or a label, okay? And numbers you can do mathematical operations on. So 1 plus 1 is 2, 2 times 2 is 4. A zip code you can't add together, you can't subtract, you can't divide zip codes, right? So it's not really a number, it's just like an identifier. And the phone number will have a certain pattern, and the email address has a certain pattern. So we're going to create a user-defined function to say, like, if the pattern matches email, if the pattern matches phone number, if the pattern matches a zip code, so on and so forth. Then we're going to identify this as a classification for identification or for the description of these different elements of data, right? So, and there's one other function I defined here, is likely company, just to say if the company kind of looks like this and kind of looks like, it follows a certain pattern, because it's not always going to be like incorporated, right? LLC, limited, technologies. You see that a lot, but there's exceptions to that rule too. And when I first ran this, I had some corporate names going into persons' names or even into city names, right? So a corporation is a corporation. Like Microsoft is Microsoft. That's an entity. It's not an address. It's not a person's name, right? So I had to create a user-defined function just to parse out the data and make it more usable, user-friendly, and make it more adaptable, and just to get this into a form where we can parse the data, okay, and make it usable in a format. Like when you see this over here, when you see this format, this is completely not usable, okay? That's totally nonsense. But when you create user-defined function, you can customize how the data is articulated or sorted or parsed into different fields into a data frame. So we have the first part we already did. The data is all jammed up into one specific column, right? And that's nice, but it's not very user-friendly, and it looks, personally, it looks kind of ugly, right? So when we run this script right here, we get the raw data. This is what comes in as. And now the logic that I just created is trying to identify what this is. What is the type? Is this zip code, email? It's unknown. This is unknown type. This is an email. So it knows this is an email, right? It knows this is a zip code. It has 5 characters. I wouldn't call it a number, because the zip code is really not a number. It's more of a character assortment, right, or assembly of characters. This is a name, right? And this type is email. Okay, so it's identifying these, and this is fine. I think this is fine. This is not company. This is the name. This is the person's name. This is unknown. Okay, so this kind of looked like a name to me, Clemens Garcia, but the model actually couldn't find an actual solution for this, so it just goes into unknown. This looks kind of like it might be what, like a phone number or something, but it couldn't identify this, right? Like a phone number would have slashes or hashes in it. So this goes into name. This one I think is identified correctly. This might be a mistake, okay? This logic is not completely perfect, but I think it's doing a good job. This looks like a phone number with an extension, so maybe that can be improved, but I think it's okay for now. This looks like a name. This one, it looks like a hyphenated something. It's not an entity. It's not a phone number. It's not an email address. Maybe it's a name. The business logic that I defined over here couldn't identify that. And this is a name. This is, what is this over here? This is a person's name. This is a company name. Kerry Johnson, that sounds like a law firm or something. This is an LLC. That sounds like a corporate name. This sounds like a person's name, person name. And we have a phone number over here. So that's an actual phone number. This one I couldn't identify. Baker Morales. Okay, I don't know what that is. It sounds like a hyphenated last name with no first name. Ross Haven, we couldn't identify that. And sometimes you just can't identify these things. We can go through and customize the logic more and make it more adaptable and more more scalable, I guess, and just overall refine the way that the model handles this data. But at this point, there are a couple of records here that just become unknown, and we just can't identify what that is. So like ideally and originally, we should have the first name, the last name, the email address, the phone number, the business address, the business name, the person's name, things like that, right? But you see this a lot, and they don't have that, right? Everything is just jammed into one single spot. So sometimes you just have to handle that very creatively, right? So over here, we can create another method where we can assign a confidence score for how confident we are with these assignments, right? So we're saying that this right here kind of looks like a phone number with an extension, but we don't know for sure. This looks like a hyphenated name. So this is unknown as unknown assignment. And this one right here is a person's name, right? So if I scroll up, we have a couple companies here and here. We have a phone number, and I think we have a couple email addresses at some point. Where's the email address? There's the email address. And I think we have a couple zip codes. Maybe not. Maybe there's no zip codes. Okay. It's not. Okay. So sometimes we just can't identify what the item is or what the recommended data assignment should be, and that's okay. But we can also assign like a confidence interval or like a percentage of confidence. How confident are we with this assignment? So that's what this script over here does. So I created one more user-defined function. If entry equals email, return 1. If the email entry is full email pattern, return 1. If it's a phone pattern, return 1. If it's a zip code, return 1. If it's a company. So that's how this business logic works. So we can see when we make these assignments, like how confident are we in making these decisions? Like this is unknown. We don't know what that is. 0.5, 0.5, it's unknown. So 1.0, this is email address, and we got that right. Okay, so that's totally right. This is a zip code, and we got that right. And this is the last name, and that is 100% correct. So we have 100, 100, 100, 0.5, 0.5, right? So low confidence. This is 100. This is a phone number. Okay, so if we look, 644-861-5234. So that matches the pattern of phone number, 100% correct. The next one is a name. This is Elizabeth Walters. That is 100% correct. This is unknown, right? So this is one half correct or 50% correct. We don't know what that is. This is an email address. We have the ampersand in there. And this is the email address, and we're 100% correct. So there you go. Just like a concept, an idea, just an innovative thought about how to take data if everything is jammed into one column, or maybe even have two, and you have to merge those or split those out. This is how you just organize your data and structure it in a format that's more meaningful, has a purpose, and like a human being can understand. If I look at this right here, right, I don't know what the heck this is. I don't know what that is. I see a bunch of stuff. I can kind of like try to make sense of that, but I don't know what that is. When you apply some business logic, some regex matching, and some user-defined functions, classify entry is likely company, right? And parse that out and just clean up the data and refine it into a state where people can kind of start to make sense of it and say, I think I know what this is. I think I know what that is. I think I know this other thing as well. Then it makes more sense. And then you can start to make more intelligent and more informed decisions, right? So that's what this exercise was about. If you have names and addresses and zip codes and cell phone numbers and everything, including the kitchen sink, jammed into one single column in your database, this is how you parse it out, and this is how you start the cleaning process. And I'm not saying this is done. There's more work to be done here, but this is a good first step. We've cleaned this up, we've refined the data, and we're in a state right now where we can start to make improvements, right? And hopefully design the database better, in the next state, so we don't even have to deal with this, right? Like the garbage in, garbage out kind of scenario. If we have garbage in, we have to clean up the mess and make it structured and make it useful and make it practical too, okay? So that's what the exercise is about. So hopefully that was informative and useful for you. I'm going to wrap it up right here, and I'll see you guys soon in the next video. Take care for now.